class, this is Uace so taking you through A-level inorganic chemistry. So in this video, we are going to be handling industrial processes, and we are going to be looking at manufacture of different elements or compounds in the industrial basis. So this video is presented to you by Uace, and you are advised to share and subscribe the channel to your friends so that you can all benefit as a family. For industrial processes, we are going to begin with the industrial manufacture of chlorine as a gas. And we are saying that chlorine is mainly manufactured by electrolysis of brine or concentrated brine. Another name for brine can be concentrated sodium chloride solution. And we are saying that it is manufactured by the process of electrolysis. So in this process, we shall be mainly using graphite as our anode electrode and mercury as our cathode electrode. So you are saying that during the process, now remember that the presentation I give you here is the same presentation you are supposed to give whenever you are prompted to answer such questions. So you're being told that this is a manufacturing or polymerization is a compulsory number in paper 1 of chemistry. So here we are saying that brine, during electrolysis, brine first of all is going to be decomposed by the electric current according to the following equation. And you have been given an equation telling you that brine, which is the same as concentrated sodium chloride. Now someone may say, why you are saying that this is concentrated sodium chloride, but you're using aqueous. Now the reason for this is because in the laboratory or in anything in nature, we don't have anything that lacks any component of water, however concentrated it may be. So that's why we prefer using aqueous. So sodium chloride in its aqueous state is decomposed by the electric current to give sodium ions in aqueous and also chloride ions in aqueous. So I forgot to indicate the state, make sure that whenever you're taking your notes, you indicate it. So we are saying that the chloride ions are going to be discharged at the anode so that chlorine gas, which is the main purpose for this process, is formed. So at the anode, always at the anode, we discharge anions, and brine is only containing a high concentration of sodium ions and chloride ions, because brine is the same as a concentrated solution of sodium chloride. So that means that the anode, chloride ions are going to be discharged in preference to the hydroxide ions because they are present in a high concentration. So two chloride ions get discharged to evolve chlorine gas. So the observation at the anode will be effervescence of a greenish yellow gas at the anode. So balancing up the equation, you add 2 electrons this side so that you can balance up the charges. You put a 2 here so that you can balance up the atoms. So proceeding, we are saying that industrial manufacture of sodium hydroxide. Now notice that sodium hydroxide has a similar way or a similar pattern in which it is manufactured like chlorine gas. So the two are linked, and that's why I interjoin them one after the other. So we are saying that sodium hydroxide is manufactured mainly by electrolysis of the brine, and we are going to be using graphite anode and a mercury cathode. And we are going to be using a cell of Castina-Kellner cell. So that's what you're going to be using for our electrolysis. Always electrolysis to occur, you start by decomposing the electrolyte that you are dealing with. So most students forget this step and they lose marks. So brine is decomposed, and it's always decomposed by the electric current according to the following equation. So sodium chloride in aqueous state is decomposed to sodium ions, which are present in aqueous, and also at the same time it gives off chloride ions, which are also present in aqueous. So you are saying that the chloride ions are hence discharged at the graphite anode. Now when they are discharged at the graphite anode, we form chlorine gas. So chloride ions get discharged to chlorine gas, and I've told you this is occurred at the anode because at the anode is where we discharge anions. So chloride ions are discharged always at the anode to evolve a greenish yellow gas, which is chlorine gas. We balance atoms first, that's why we put a 2 here, and then you balance charges. This side we have a -2, net of -2 charges, so that's why we put 2 electrons this side. Now, since the experiment is not about manufacture of chlorine, instead the sodium hydroxide, we have to proceed. So that's why we are saying that sodium ions, the cathode always discharges cations. So sodium ions are discharged at the cathode because they are present in high concentration. Remember, brine is a concentrated solution of sodium chloride. So sodium ions are discharged to give us sodium, but this sodium is going to be in liquid form. Now you're saying that the sodium that will be formed combines with the mercury to form sodium amalgam. So sodium in liquid form combines with our mercury cathode, which will also be in liquid form, and we shall form a covalent liquid of sodium amalgam. Now what happens to this liquid? This liquid readily dissolves in water. That's why we are proceeding with this sentence, and we are saying that the sodium amalgam, which is a liquid formed, moves to the water tank and reacts with water to form sodium hydroxide, which is the aim for this experiment, hydrogen gas, and also regenerating our mercury cathode. So the equation is highly common and I covered it in your O-level. So we shall keep examining in paper 1 specifically these processes, and you have to master each and everything as I presented it in this notice. So you're saying that 2 moles of sodium amalgam react with 2 moles of water to form 2 moles of sodium hydroxide, 1 mole of hydrogen gas, and 2 moles of our mercury cathode. So lastly, we are going to be looking at the uses of sodium hydroxide both in the environment and in the laboratory basis. So we are saying that sodium hydroxide, first of all, used in the manufacture of soap. For those of you who use liquid soap at home, you are using sodium hydroxide. And also, sodium hydroxide is used in the manufacture of rayon and papers. A book is a good example for such a point. And we are saying that purification, sodium hydroxide is also used in the purification of bauxite in aluminium extraction. Now, aluminium is an extension of period 3, and the video is already uploaded on this channel. So whenever we are purifying, during the purification process, we use sodium hydroxide to dissolve one of the impurities, which is silica or silicon oxide, and also our ore, which is aluminium oxide. That's when during the purification stage, as the video has been uploaded and well explained on this channel. So if you haven't watched it, you're advised to go and watch it after this video. So let's look at the next process, which involves mainly the industrial manufacture of nitric acid on an industrial basis. So we are saying that dry hydrogen obtained from natural gas, and dry nitrogen obtained from fractional distillation. And this is by fractional distillation of liquid air, as you covered this in O-level, are mixed in a 3:1 ratio or proportion by volume. respectively. With respectively, I mean you are going to need 3 moles of hydrogen or 3 volumes of hydrogen and 1 volume of nitrogen. That's what the word respectively means. Respectively means in that order. So we are saying that the mixture is then heated. Now you're going to look at this in chemical equilibrium. The mixture is then heated at a temperature, and this temperature is going to be of about 450 to 500 degrees Celsius at a pressure between 200 to 500 atmospheres, and it's going to be done in the presence of a finely divided catalyst, which is always iron, to form ammonia. Now this is a reversible reaction. We are going to be looking at it in chemical equilibrium, which is the next topic to be explained on this channel. So 3 moles of hydrogen react with 1 mole of nitrogen, and that's a ratio of 3 to 1 by volume, if you consider Gay-Lussaca's law. So hydrogen and nitrogen react in a ratio of 3 to 1. I've told you this must be a reversible arrow to give us 2 moles of nitrogen, which is present as a gas. And we are saying that ammonia obtained is then dried and mixed with excess dust, free air, and passed over the platinum to rhodium catalyst. Now these ones are to speed up the reaction. Catalysts always speed up the reaction, but they do not engage in our reaction. So the platinum rhodium catalyst at red heat at a temperature between of about 900 degrees Celsius, and the pressure which is maintained relatively low, and in this case we are saying that the pressure will be of about 8 atmospheres, and this will be used to form nitrogen monoxide and water. Now when you are setting these questions, we set them mainly in paper 1, and we examine them in such a way that we can just tell you to summarize all the equations involved in the preparation of nitric acid. So the theory behind the equations I gave you is to help you remember properly so that you don't make mistakes in your papers. So 4 moles of ammonia gas are going to react with 5 moles of oxygen gas, and they are going to give us 4 moles of nitrogen monoxide gas and 6 moles of water. And we are saying that the nitrogen monoxide formed, which is up here, because we are proceeding one preparation of nitric acid and one nitrogen dioxide. So that's why we are saying that the nitrogen monoxide formed. Now another mistake, students usually combine these words. Always these words are two. Nitrogen and monoxide, carbon and dioxide, those are two words. It will lead to loss of marks. So we are saying that the nitrogen monoxide formed is rapidly cooled and further oxidized by oxygen from an excess of the air to form nitrogen dioxide. As I've already told you, the theory behind these equations is to enable you memorize. By the major things that we shall examine here, we shall examine you to state all the equations involved in the preparation of nitric acid, and you should know how each of them is balanced. So you're saying that nitrogen monoxide is going to be oxidized by excess oxygen, and by doing so, it's going to give us nitrogen dioxide gas. And I've told you nitrogen dioxide are two words, like I included it here. So you must leave a space between those two words. So we're saying that the nitrogen dioxide obtained from the reaction above in presence of excess air is then absorbed in hot water. In presence of excess air is then absorbed in hot water. So this was a typing error. You make sure that you cross it. The nitrogen dioxide obtained is then absorbed in excess air, in the presence of excess air, and absorbed in hot water, and this will help us to form nitric acid, like it has been presented in the equation. So in the equation, you are seeing that 4 moles of nitrogen dioxide gas are going to react with 1 mole of oxygen gas to form with 2 moles of water as a liquid to form 4 moles of our nitric acid, which is the purpose of the experiment. So how many equations are involved in this process? We had the first one on the previous slide, this one, second one, this one is the third one, and this one is the fourth one. So those are the number of the equations we shall examine you in each and every paper 1 of chemistry to present as you are preparing or manufacturing nitric acid. So moving on to the next step, we are going to be looking at the industrial manufacture of sulfur dioxide gas, also the industrial process. Now there are very many ways of how we can manufacture sulfur dioxide gas, but I only listed one to avoid confusion. So we are saying that sulfur dioxide can be obtained by burning sulfur. However, as we are proceeding with our organic, you are going to see also other compounds that can form sulfur when heated. So we are saying that sulfur, and it's okay to use them, but this one is the simplest. That's why I used it in this video. So we are saying that sulfur dioxide is prepared by burning sulfur in excess air. That's why we are having 1 mole of sulfur reacting with 1 mole of oxygen gas to give us 1 mole of sulfur dioxide gas. We are seeing that the sulfur dioxide gas obtained above, and the oxygen obtained by fractional distillation of liquid air are purified together, and both of them are reacted in the presence of a catalyst. And which catalyst do we use here? We are going to use vanadium 5 oxide catalyst. Always note this catalyst because we always examine it. And also, for those of you who are taking notes, you make this one a reversible arrow. It's not a straight arrow. And we shall be looking at this in chemical equilibria, which is the next video to be uploaded on this channel. So the purified and dried gases are passed over vanadium 5 catalyst at temperatures between 450 to 500 degrees Celsius and pressures which are between 1 to 3 atmospheres, so as to form our sulfur trioxide. Sulfur trioxide is also a gas. So according to the equation, you are seeing that 2 moles of sulfur dioxide are going to react with 1 mole of oxygen to form 2 moles of sulfur trioxide gas. So in the next statement, we are saying that the sulfur trioxide gas formed, is then dissolved in concentrated acid so as to form a fuming liquid of oleum. So the sulfur trioxide we form, we dissolve it in a little concentrated sulfuric acid, and when we do so, we form a liquid which is oleum. Now there's no need to cram oleum, you just add the atoms that you're having. Hydrogen, there are 2, that's why I put here 2. Sulfur you're adding so that you're getting 2 sulfur atoms, that's why there are 2 sulfur atoms. Oxygen you're adding 4 plus 3 to give you 7. So remember that whenever you're dissolving sulfur trioxide in concentrated sulfuric acid, you are only adding atoms to get a liquid, a volatile liquid, which is oleum. Now we are saying that to convert oleum to the concentrated sulfuric acid we want, we are going to dissolve it in a correct amount of water, and this is going to yield us 98% concentrated sulfuric acid. So that's why you're seeing 1 mole of oleum in its liquid form, because it's very concentrated. That's why we are presenting it in liquid. Oleum in its liquid form reacts with water, which is also present in its liquid form, and they are going to give us an aqueous solution, which is 98% concentrated sulfuric acid, and there are 2 moles according to the equation. Now we only form sulfuric acid, there's no other product which is being formed. So you have to take note of that. So going to number 5, the concluding statement, we are saying that the sulfur trioxide is not dissolved in water. Why? Now you look at this reason in O level, and we are saying that the reason behind that is because that reaction is highly exothermic. So that's why it's better to dissolve it in concentrated sulfuric acid. And we are saying that if the reaction is so exothermic in that way that it will lead to formation of sulfuric acid separase, which can damage plants as well as animals like you. For part C, now here we are talking about reactions that are involved with these processes. Now we are saying that sulfuric acid does not react with hydrofluoric acid and hydrochloric acid. Why is it the reason? And we are saying that the reason behind that is because the fluoride ion and the chloride ion have a very small ionic radii. Both of them have a very small ionic radii, hence making their hydrides have a very weak reducing action. That means that they are not very good strong agents. But we are saying that hydrobromic acid and hydroiodic acid, for them, are strong reducing agents. And the reason for that is because the bromide ion and the iodide ion have a very large ionic radii. Therefore, they reduce hot concentrated. Having a large ionic radii enable them to be good strong reducing agents, and therefore they reduce hot concentrated sulfuric acid to form sulfur dioxide gas, as they are oxidized to bromine and iodine respectively. So for bromine we shall see a reddish brown liquid, and for iodine we shall see a reddish brown vapor, and for iodine we shall see purple vapors. And this experiment is very common in your practicals, where we tell you that to add concentrated sulfuric acid and you heat. This is always what you are looking for. So always pay attention to your practicals on this part. So we expect you to either see purple vapors or you see reddish brown vapors, because bromine in its liquid form is a reddish brown liquid. That means that if it's producing its vapor is also going to be reddish brown. And the same applies to iodine. They are observed respectively, and the equations given are also given in terms of respectively. So you'll see that 1 mole of sulfuric acid being concentrated, we gave it liquid, but also student who writes aqueous is marked correct, reacts with 2 moles of hydrogen bromide or hydrobromic acid to form 1 mole of bromine gas, sulfur dioxide gas, and water. Now these are redox reactions, and I've taught you how to balance redox reactions. You try to balance these equations using the knowledge you obtained from redox reactions. So 1 mole of sulfuric acid reacts with 2 moles of hydrogen iodide to form 1 mole of iodine gas, and 1 mole of sulfur dioxide together with 2 moles of water. That's been all for this video. You are encouraged to share the video to your friends who haven't got this knowledge yet. And for those of you having exams, we wish you success.